In this video, we're going to discuss what a line of symmetry is. And when we do that, we want to kind of go over a couple things. So, something is symmetric if you can fold it over a line and it fits exactly on top of itself. So, that's kind of our word here. We're looking at the word symmetric. The line you fold on is called a line of symmetry. So, when you're dealing with this and answering questions about it, you're thinking, like, is this shape symmetrical? Can I fold it over itself? Where would the line of symmetry be? So the first example I want to talk about is going to be right here, this rectangle. And you can see that if you kind of look, if you put this right about halfway down, you should be able to fold it over this line and it will match up exactly itself. Along with right here, straight across, if this was right in the middle of it, it would fold over on top of itself and you have another line of symmetry. So there'd be two there. What would not be a line of symmetry, that would be, so I connected these diagonal corners. That would not work, because if it folded over, it wouldn't fold on top of itself. However, if I change this shape to, say, a square, and looked at it more like this, well, then in a square, those lines would fold over and you have the two triangles on top of each other. They'd actually be right triangles, right isosceles triangles. They would fit right on top of each other, and that would work for both of them. And then you'd also have the horizontal and the vertical and the horizontal lines right there for lines of symmetry. So a square would have 1, 2, 3 different lines of symmetry, where 1, 2, 3, 4 lines of symmetry. 4, and this would only have 2. And then you have a circle, which is a completely different animal, because a circle, if it's constantly, if it's perfectly round, there's an infinite number of lines, and you can indicate infinity by the sideways 8. There's no total number of lines for a circle, it's infinite. I just thought I'd point that out. The circle has a lot of lines of symmetry. Let's zoom in here and look at this star and look at the symmetry here. A star has symmetry, and within that, you're looking at basically from each point straight down, it could be folded across and line up perfectly. So when you're figuring this one out, you really just have to think, okay, how many points are there on a star? There's 1, 2, 3, 4, 5. So we have 5 points, which means that you'd have 5 lines of symmetry here. And so that's kind of how you would figure out line symmetry. The tricky part is looking at a shape and saying, does it have any? Because sometimes it doesn't have any. Like, you might look at this shape and say, oh, can I draw a line this one? No. What if I went right through the point? Kind of no, they're not quite lined up straight. So it's hard. You sometimes just say, oh, this one just has 0. There are none. No lines of symmetry. And finally, just one little comparison going back to the circle here. A circle might have infinite, but if you just take that circle and stretch it out into, say, an oval, like this, you no longer have an infinite number. You end up with just 2. And those 2, one would go straight across the middle down this way, and one would go this way. It ends up, it's like a square has more than a rectangle, and then a circle has a lot more than an oval, because if you stretch it out, this line that I put across the middle here, it wouldn't fold over on top of itself, so that's not a line of symmetry. And let's just kind of go back and review that something is symmetric if you can fold it over a line, if it's exactly on top of itself, and then the line that you fold over is called a line of symmetry.